let's start with this ModelRisk demo. So this is an introduction to ModelRisk, and the good thing is that please interrupt me at any time and ask questions. The idea is this should be a conversation. I'm going to show you a simple model, a simple cost model with ModelRisk. And before that, just a little bit of story of ModelRisk itself, right? ModelRisk is built by a company called Guz Software. Guz Software has its heads office in Belgium with more than 25 years of experience doing that. At the beginning, they started as consultants and trainings and in quantitative risk analysis, and they evolved and they become a company which fabricates and manufactures this software. Right? Currently, they have three main pieces of software that they develop and support. One is ModelRisk that has almost 20 years on the market. Right? The one that we're going to show, it's a really nice piece of software. Then we have Tamara and Pelican. Tamara is used for scheduling risk analysis and Pelican for enterprise risk management. And these three, they generate, let me show you here, what we call a Pelican system, or the Pelican risk system, which is basically what you can see now in the upper portion is Pelican. You see, it's an enterprise risk management system where you have Monte Carlo simulation, but also you have all the different portions of an enterprise risk management system very aligned with quantitative practices. So you will have bow tie analysis, you will have all the business units and project risks included there, so you can manage your whole company's risks from there. It's an amazing tool, and we're going to tell you maybe during November we're going to do a demo of Pelican, which is amazing, right? So Pelican, the main idea of this is that Pelican would be a host of a centralized hub for, first of all, project risk, and this is what I'm showing you right now is Tamara. Tamara has capabilities for importing P6 or MS project models and then adding risk to them, right? And then communicates with Pelican. And also the main idea is to generate a virtuous circle where ModelRisk, the one that I'm going to show you today, is going to be, right? And again, you can upload and exchange information with all of them. So the idea, of course, is that ModelRisk and Tamara, of course, are going to join together. So the main idea here is that you will have a platform where you can have and calculate the complete risk of your company, and you can granularize it both in projects, whether it's in the schedule arena or is it in the cost arena, like the model that I'm going to show you today. Right? Some of the customers, and I think that I skipped this one, as you can see here, I mean, you can start with defense, insurance, technology, retail, manufacturing, oil and gas, mining, etc. So this is pretty agnostic in terms of industry. That means that the methodology that it uses and the software itself is built to be aligned to any of these different industries. So thanks again for joining. And what we're going to do, a quick demonstration of what does ModelRisk do, right? So of course it can quantify risk, it can aggregate it, it will simulate it, right? But what else you can do with that? And perhaps this is going to generate one or two different ideas, right? This works on top of any Excel model. It has 136 distributions, so that means that you can start very, very small in terms of the complexity of your models, of your study, etc. And then you can go really, really advanced with extreme distributions, with some manufacturing distributions, etc. What we're going to do today is include uncertainty and risk events, the typical framework that we're going to use today. We can model scenarios, we can model correlation and copulars in case you're familiar with them, and you have complete reporting capabilities. So any model that you have, you can generate reporting out of the box without having to design everything. Of course, you can design it, but if not, you have the ability to do it from the application. Again, simulation only. Of course, simulation is at the heart of ModelRisk, right? That's how it was built for. But we have more things there. One is a portfolio optimization. If you use, or if you're in the investment arena, so we have an KPM model. internally developed for this, right? We can integrate with Pelican and Tamara, as we said before. We have a really nice, and this is something I really like, the time series modeling module that has more than 30 time series. So in case you are in the manufacturing or industry, if you want to predict, I don't know, commodity prices, interest rates, inflation, things like that, you can use the time series module. And you have a data and a results viewer. The data viewer permits you explore the information that you're going to pour into the model, and the results viewer permits you, and this is the one that we're going to see today, permits you explore the results of the model. The results viewer, and this is a very important thing, the results viewer is a free tool that you can install, right? And you can share information with all the people that have the results viewer installed, right? So that's a nice piece of software there. I'm going to, with you, Rodrigo, in 1 minute. I just wanted to finish this. We can manage what we call the simulation imported data management, meaning that you can have different simulations stored in your computer, and then you can compare them. And for the decision-making process, of course, we can report on the key drivers, right? As for technical requirements, you would need Windows 10 or 11 to run it. Any Pentium-compatible machine, I have an i7 here, but with an i5, that you'll be okay too. Hopefully you have 8 gigs of RAM. This is not a space eater, it's only 10 gigs. And these are standard screen and software prerequisites. We're compatible starting with Excel 2013. I imagine that you will be more in the 2016 and 19 or 365 version, but in any case, we can support all these old versions. So this is a little bit of ModelRisk. And I think, Rodrigo, you had a question. No?
No, so probably I will do the question when we can talk alone. It's about the time series functionality that in my experience, it gives a very wide range. Well, but let's talk it later.
Not a problem, Rodrigo. Rodrigo, it's an old friend from the Voice software company, and
yes, I'm very happy with the software.
Yeah. He's a very loyal user, so
yes.
he could be a good testimonial for you guys.
Yes.
So let's start with the cost and risk register, right? So ModelRisk, I'm going to show you here. ModelRisk is a, let me start my pointer here. It's an add-on to Excel here. So if this is the first time you see it, right? ModelRisk is going to sit on top of Excel here. And it will generate all this functionality that will sit on top of Excel. That means that it's not invasive with your models, and you will see how we do it here in this cost model, because it will add some layers on top of that. So let's see that you have a cost model like the one that I have here, right? Let me admit Daniel. So if I have a cost model here, let's say I have my cost model in Excel, right? What's going to happen is that here on top of that, it will be ModelRisk, right, with the distributions. And on top of that, you will have the results, right? Like this. So the logic that you have here in your cost model is going to remain intact. That's a good thing about this. You don't have to replace the logic of your model or to recreate your models, because the layers that we're going to do are like a sandwich, right? It's going to be one layer after the other after the other. Okay, so let's start with this. This is a simple cost budgeting model, right, for a project where we have a design, preliminary engineering. This is how we were thinking about a water pipeline. This is a project that I worked here in my country, like, I don't know, maybe 8-9 years ago. You have to test refinements and details for laying the pipeline, etc., the final delivery and the documentation. For this, you will have, let's say, $4.3 million, right? And any number is fine, because what we want to do is to see the operation and not focus that much on the logic of the model, right? And what we did, and this is what we call a deterministic scenario, right? deterministic, and this is something that you will find in the literature as a static model or a deterministic model. And this model here, right, as let's say the best estimations that my subject matter expert came with, and this is 4.3 million. In terms of risk, I had a contingency of 5%, you see? Right? Because I said, well, these are the best, these are the normal practices of the company, and my contingency will be 5%. And I said that I have some risk mitigation controls, and these mitigation controls are going to cost 100,000. So my total cost and risk are going to be 4.6 million. Right? As I don't have a tail, or I don't have in this case, a distribution, my risk exposure, I don't have it, right? I cannot, maybe I would say it's 215,000. That's what people suggested, but normally I don't have a risk exposure. And this is what we call, again, a deterministic model. So how do we evolve from this deterministic model to do more of an uncertain model, right? And the uncertainty model, which is this one here, what we're going to do, we're going to add, and we're going to start thinking in ranges. This is the key word here, right? Ranges. If we start thinking in ranges, that means that the design phase, instead of knowing that upfront it will cost 500,000, perhaps it will cost between 450 and 700, with a most likely value of 500. You see, 400 and 700 with a most value. So if you do this if you kind of visualize this, right, you will have 450, right, here, most likely 500, and the maximum of 700, like this. You see, and if you want to generate a distribution, that will be something like this. Right? This will be a triangular distribution, right? It will be between 450 and 700 with a most likely value of 5. Right? This will be the mode. So we have, of course, if you're interested, we have a training on QRA where we explore all these things during 4 hours. It's a master class on that, where we have some, fun models to play with and generate distributions and all that. So what happens with this? We started to talk in ranges with the minimum, most likely, and the maximum value, right? So this, instead of being the cost, is going to be the most likely value. And we did this for all of them. You see? So the exercise is very interesting, because what happens is that you suddenly have a range for your results, right? Between 3.4 to 7 million, right? With a most likely value of 4.3, right? The one that we had before. So just as an exercise, adding the ranges brings a lot of value to the table, right? Because this, of course, requires the effort of the subject matter experts here to generate these minimum values, these maximum values as well. And of course, you've already had the reference values. One tip for this exercise is, hopefully, when you ask the subject matter experts about the minimum, most likely, and maximum, you ask for the min first, the max second, and the most likely at the end. Otherwise, they would say, I don't know, design is 500 plus minus 10%. You say minus 10 plus 10. Right? Which is something that really invalidates the exercise, because what we want to capture are the tails, right? Why? Because the tails of the distributions is when the risk is, right? So that's why I wanted to capture all of this with a good exercise. Now that I have the ranges, right? This is an exercise that you can do directly in Excel. You can build a distribution like the one that I have here. So I will show you to you in this other, you can go to select distribution, and here you have a palette where you can select one from the 100 and something. You have this most used distributions, and you have some, you see, discrete, continuous, event size, frequency, unbounded, left bound, etc. So you have, depending on the use of the distribution, you have many, or normally I will go with this, with the common ones. So normally, if you ask me, you will need maybe half of this to start working with Monte Carlo simulation. So you don't be scared. That's the idea of this introduction, because it's very simple for you to add these distributions, right? So this per distribution that I'm going to select here, right, has 3 parameters. Every distribution has some parameters. So these 3 parameters are the minimum, the mode, or the most likely, and the maximum. In our case, I'm going to change this. I will change it in the very manual, right? 450 500 and 700, like this. You see? And this is going to be the distribution that you got from your subject matter expert, right? Maybe he didn't know, or she didn't know that this distribution was going to look like this, but these are the values that they had because they did the analysis. That's the main idea, right? Now, you can do things a little bit more advanced, like truncating the distribution, like saying the distribution goes from here, or shifting the distribution, like sliding it into the axis. For today's, we're just going to use the main parameters of the distribution, minimum, mode, and maximum. Right? And we did this for all of the distributions, and for all of the items here. So we generated a per distribution for all of them, which are here. And you will see you have a post per distribution for each one of them, right? And also you see that you have this VOS input that has V6 as the parameter, and basically this is the name of the distribution. Why do we need a name? And you will see that after we run the first simulation, we will have a tornado chart. And this tornado chart is going to show you the key drivers. So the key drivers, they need a name so you can see which are the variables that affect the most of the model. That's why you need the name, right? So you do the VOS per distribution like I just did, right? And then I just did this VOS input, which basically is taking all of this together and saying input here. You see, you have outputs or inputs. The input, and then I choose the names like this. You click in OK, and this is going to generate all of them together. So you don't have to do one by one. Now, this is the first step. Remember, we have the model logic. The model logic is this. It's a simple summation. This is the model logic, right? It's a sum. So what we're going to do, we're going to replicate this sum here. Right? Here we're going to replicate this sum. But now we're going to sum the distributions. And this is where the Monte Carlo simulation enters. So let me explain to you what Monte Carlo simulation is in a second. Right? Let's say that we have 3 distributions, right? Instead of all this, 7 or 8, we have 3. And we're going to run a Monte Carlo simulation process. The process, the Monte Carlo simulation process, requires a given number of iterations, like the one that I have here, right? See, you see, it's 5,000, but let's say that we're going to run 100. So what this is going to do is going to grab random samples from the distributions, right? Let's say here, here, and here. It's gonna replace them in each one of these items, here, and here, and here. And of course, it's going to do the summation because this is the logic, right? Here is the logic of the model. And this is going to be iteration number 1. If we go to iteration number 2, let's say I have a sample from here, from here, and from here, and it happens the same, right? Each one of them goes to the model, and the model does the summation. Let's say number 3, same thing, right? Each one of them goes to the model like this, and it's the simple summation. Here, the logic can be anything. In this case, it's super simple, but the logic can be anything, right? So this is going to be run 1,000 times, 5,000 times, right? And what happens is that all these results that we had, right, these 5,000 results, are going to be grabbed and are going to be stored, right? They need to be stored, right? These 5,000 results. That means that I'm going to run the model 5,000 times, right? So I need a placeholder where to put all of this. So what's going to happen is that you will see here, I'm pressing F9 in my keyboard. You see, all of these, they change together, right? Like this. And this is the beauty of Monte Carlo simulation, because Monte Carlo simulation makes reality a little bit more similar in a model. Why? Because everything moves together, right? It's not like you just leave everything constant and you just move one variable. In this case, you move everything together. And the logic is still here, remember, with the summation. The only thing that I did here, let me just copy the name. I generated the placeholder. Remember that I said that we need a placeholder like this. So I went here to output or input, and I say, I want an output that's going to be called total baseline cost. That means that this cell is going to be an output. I click in OK. you see that it's added here, right? So then I have my first model because I have the three main components of a model, which are the inputs, the distributions. I have the logic of the model, which is the simple summation, and then have the output. And the output in this case is the total baseline cost. Once I have that, I added the first component of the model. You see that I said before, when I was showing that you can add two things to a model, uncertainty and risk events, right? Which if you do a graphic, they will be like this, right? Uncertainty, you put it in red. Like this. So this is going to be uncertainty, and risk events, right? This is going to be a big distribution, like this. So uncertainty is what we're building here. And it refers to the natural oscillation of the variables, meaning that you know that, for example, the preliminary engineering, it could cost between 350 and 600. You don't really know what exactly will be the cost at the end of it, because I don't know, let's say that it takes a month and a half. So you have vacations in the middle, people can get sick, people resign, you have to hire and train new people. Right? There are things that people don't know, you have to hire consultants, things like that, right, to make this happen. So that's why this is the natural oscillation of the variable. The risk events, contrary, the risk events are all these events that could happen that in its majority of time, and for this case, we're going to think about potential negative impacts, right? And we're going to see that in a minute. Okay, so we are working with uncertainty. So this is the uncertain portion of the model. Okay, so now that we have inputs, the model logic, and the output, which is this, I'm going to run a simulation. You see here, I have this play button, right? And I have the number of iterations. First of all, I'm going to run 1,000 iterations. That means that I'm going to get 1,000 samples for each one of the distributions. So you just press play. This is not going to change or hurt or damage your model in any way. So you can do this as much as you want, right? So you press start, and this is going to appear, right? It goes really quickly. Let me do 2,000, because it was really, really quick. So let me do start. You see, it goes like this, and it finishes. And it shows you what I told you before, which is the results viewer. This is the results viewer. This is a piece of software I really, really like, because it lets you explore the model in many, many different ways. I have here all my inputs. You see that I have inputs for my costs, which are here, and for my risk register, which I'm going to show you next, which are here. I already have mapped some inherent and residual risk. I'm going to show you in a minute, but I have my total baseline cost. And I have also a simulation where I can generate many simulations, as I said before. Now, so what happened here? Right? If you remember basic statistics, right? That means that now your variable, your cost, is no longer one number. It's a distribution of numbers. It's a set of random numbers, which are, and you can see that here, right, between 3.7 and 6 million, right? This will be the cost of your model. 3.7 and 6. So you remember that we said here in the basic ranges, that it was going to be between 3.4 and 7. Now we know that it's 3.7 and 6. Why? Because these scenarios that we built were scenarios where everything is fine, everything is the best, and everything is the worst, right? But normally, when you run a distribution like this or a simulation like this, they don't happen like that, right? It's not like you have the worst preliminary design and the worst final delivery and the worst refinement and the worst testing, right? You normally learn, right? And if it's the case that you want to anchor somehow the variables, you can use correlation, and we can do that in a second demonstration, right? But in this case, assuming that the variables are going to behave normally, I mean, regular, usually, this is going to be the range. So remember, the x-axis here is going to be the range, of the variable, 3.6, 3.7 to, is it 6 million, like this, more or less. And the y-axis is the probability. That means how much or how many of these numbers are going to be in each one of these bins, right? You have these bins that you have there. So that means that, for example, here you have X number of values that are going to be here, X number of values are going to be there, etc. So what can you do to relate this to the number that we had before? For example, you can say that this is going to be 4.3 million. So let's see where is the point 4.3. What I can do, I can go to the options here and say I want a marker. That marker is going to be a value, and that value is the 4.3 million that I had before, right? And I'm going to start to show how is it that you can read this. And you can see it here. The 4.3, you have 24% probability, which is basically this, 24% probability for the total baseline cost to be less than this value, right? To be less than the reference value that you had before. So that means that 1 in each 4 times, if you run this project many times, 1 in each 4, you will spend less than the budget, which is good, right? Because maybe you can sell this project to other person, and that means that you are going to be 75%, I'm sorry, 25% probabilities are going to be in your favor. But that means at the same time that you have all of this, meaning that 75% of the time, that means 3 in each 4 times that you run the model, is going to be against you because you're going to spend more than your budget, right? Which is this. So if you ask me, right, maybe this is not a really good and positive scenario, right? Because only 1 in each 4 times I'm going to be spending less, and 3 or 4 times, or of each 4 times, I'm going to be spending more. Yeah. And this is why you have these types of graphics where you can learn a lot of things from your scenario. In this case, this is a first scenario, right? I took my reference number here for the 3 million, and I know that this is 24%. So again, 24% means that you have 24% probability of having less or equal than that, and 76% probability is that you're going to spend more of that, right? Which is not a very, I don't know, that doesn't bring a lot of stuff, right? It's a difficult situation. Now, what can you do? Because if you are in this situation, what you can do is you can ask for a tornado chart. So let me do one thing. I'm going to close it and generate a new one. And close these things and generate new ones, right? And then you can do insert tornado. And what this is going to do, this is going to show you the tornado chart, right? Like this. This is going to show you what are the key drivers of the model. In this case, this is a linear model, right? It's a simple summation, meaning that, of course, you have the implementation of the pipeline is the biggest one you see in magnitude, meaning that, of course, and it has a lot of volatility. That's why in this case, what it says that if the preliminary engineer is really cheap, your mean is going to be 4 million. And if it's very expensive, it's going to be almost 6 million. Right? And then you can see the scope of each one of the variables. So this is what we call a tornado chart. Right? And this is going to give us focus. Where should I put my money? Where should I focus my resources? Okay. Of course, we have more than 7 or 8 tornado charts here. I'm not going to show you more, but you can explore them here like this. So we have contribution to variance, tornadoes, for correlation, etc., which are also the ones that we can add. And this is going to do some things for you. As I said before, this is going to generate focus. So maybe you will focus on these 3 activities and change them somehow, right? Maybe you will find a different provider. Maybe you will find a different way of doing things, change contracts, etc. So you don't have such a big risk. And maybe the histogram here It's not 24%, but hopefully, I don't know, 50 or 60%. So you have more probability in your favor, right? So this is the first portion of the model, right? It's uncertainty only. Remember, it's the first triangle. Now what we're going to do, and I have a different tab for that. I think we're okay in time, because this is going to take us, I don't know, maybe 10, 15 minutes more, so we have time for questions. Thanks, Oki, for joining. I think Oki, our risk business commercial consultant is here too, so thank you for joining. And what I did here, I built a basic, very basic and simple risk register, and you will be familiar with this, right? Each and every one of these are potential events that could happen. They could happen one time during the life of the project, or they could happen more than one time during the lifetime of the project. For example, here, if you have resource scarcity, for example, it's a very specific project, you need special people to do it, right? What happens is that perhaps you have to use what we call a Poisson distribution, and you will see it here, right? It is a discrete distribution, right? That has an average of 4 times, meaning that during the year or during the timeline of this analysis, this distribution would happen where you have 4 here, means the number of times we have events of resource scarcity, but you can have up to 12 events, right? Or you can have 0 events too, each one with a different probability. So this is what we call a discrete distribution, right? And there are going to be risks that can occur 1 or 0 times, and for that we'll use a Bernoulli distribution. You see, so far we've used 3 distributions: PERT, Bernoulli, and Poisson. With these 3, we're going to build the whole model. Right? And each time it happens, for example, when you have this resource scarcity, you will have between $10,000 and $40,000 in impact. And with this, for this, we built a PERT distribution like that. See? So if I press F9 again, I'm generating samples for each one of them. And you see that the logic is very simple, right? If this risk happens, for example, you have an issue with the approval of the environmental study, your distribution is going to give you a 1, meaning that the risk did occur. And as the impact was going to be 57,000, you just multiply the 2, like this. If you have, for example, 5 issues with resource scarcity, and more or less you have between 10 and 40,000, each one of them, internally, the software is going to generate 5 samples and it's going to summate them. Right now, this is a simplification, but this should be the right way to do it. So this is what we call the inherent risks, right? Why? Because these are the risks that I have right now. Right? And I haven't done anything to mitigate them. You see them when you identify the risks, you assess the risk, like I did here, right? I added all this quantitative portion. If you're in a company that does risk management, that I imagine that you do, right? You will have here the owner, the description of the risk, the causes, maybe a fault tree analysis, an Ishikawa graphic, things like that, enrich the analysis for each one of the risks. Now that I have my total inherent, right? That means that this is the total impact of the risk. What I have to do is I can take this impact to the risk to my model here, right? And what I can do is I can generate an inherent risk scenario here, right? Where I copy the uncertain scenario, but I have to add the cost of the risk, right? The risk impact. So what's going to happen? Remember that I already run the simulation, is that if I see let me show you here, what's going to happen is that I have my baseline cost here, right? This baseline cost didn't include any risks, but as I included the risks, all the 5 risks that you saw, right, you can compare that to the inherent, you see? So the distribution moved to the right. You see, this is what happened. The distribution moved to the right. Why? Because you have a higher cost. And maybe, yeah, I have a lot of things going on here. Here you go. So my 4.3 million for the inherent total, now it's 4% instead of 25%. That means that I have only 4% probability in my favor, meaning that I will spend more than 4.3 million. That I will spend less than 4.3 million. Before I have 24, but because of the risks, now I have 20% loss of probability. That means that I am in a worse position right now. Why? Because of the risks. Now, things that you can do here, you see that it's a very nice, this is what we call an overlay histogram. I can change it to a cumulative ascending like this, which is much, much more cleaner, right? And it lets you do the case like I was doing here. And if you like, you can even understand the impact of the risks, right? Because you see here, I have the cost. This is my cost, which goes to this sheet. And this is my risk register to go to this sheet, right? So I can say, why don't you give me just the impact? I just want to focalize only on the impact, but I want to see a tornado chart for that. And then you can see the total inherent, right? Which are the risks that affect the most. You see? So if you want to focus now on the risks, not on the costs, you can see that you can go to the problems of the community, the project management issues, and resource scarcity. So perhaps this is where you have to put your money, right? So what we're going to do, we're going to go back to the risk register, right? Let's say, and we're going to do some mitigation here. So I'm going to hire an expert. I'm going to have an HR agency that's going to, I don't know, have more redundancy. I'm going to protect from exchange rates. I'm going to hire a PMO expert and have an agency here. This is going to cost me, right? I'm going to pay here. I don't have a distribution because these are fixed costs in my model. But what I did, and this is the effect that these things have, is that, for example, if I have problems with the community and I hire a conflict expert, so the average of problems with the community will lower from 2 to 1. The resource scarcity will lower from 4 to 2. And the same with the probabilities for the project management issues in all of that, right? That should be the deliverable of all these things. I'm going to hire someone, I'm going to hire some people, an agency, a consultant, buy an insurance policy, etc. This needs to go down. The same with the impact here. You see, before my impact was 250, 300, and 450. Now, if I do the hedge, it is going to be this, right? Because I am transferring some of the risk, for example, to a bank, right? So what's going to happen is that we're going to have a new scenario called the residual scenario here, right? And this residual scenario here, so I have less decimal points here. So this residual scenario, what's going to happen is that hopefully it will have less impact. Why? Because I invested all this money, the 327,000, so I get less impact in my risk. So if I go back to the cost is now is going to have the impact, the new impact of my residual risk, but I should include the 327,000 that I'm going to spend. So I will have to run the model again. I already did, but I will do it anyways. So I have to run the model again. So you see the operation, remember, I have this. And what I can do is I can compare, right, with the histograms, I can compare my 3 costs, right? My total baseline cost, let me put it in here as a line, right? To my inherent, that's going to move to the right, right? To the right in your screens, right? But the residual, if everything is okay, you should move it to the left a little bit, right? Because I invested money to have more impact. And this will be reflected here, you see, a little bit. So what's going to happen is that, no, it's still not that good. You take a look. It's not enough in this case. You see, so you have the baseline, which was 25%. The inherent was 4.6. And here my efforts, maybe they were too expensive, you see? So the 4.3 million that I had, it's 1%. So things that you can do, and I'm going to do just one scenario here, is that perhaps let's say that you negotiate and the PMO expert is going to cost you 50,000 and the agency 40,000. And let's say that the redundant agency is going to give you this. You see, so I'm trying to negotiate here and I'm reflecting this into the model. I lower the costs of my controls, and I increase the impact, right? So hopefully this is something that you can do, right? You negotiate with the bank, and the bank says, yeah, I can give you 100, 200, and a maximum 250, something like this, right? And then you modify the model, and you run the model again, right? And this will be the operation, right? Because this is what we risk managers try to do, right? To get the most, what we can do. And take a look what happened, right? The inherent was 4.2, and we're almost in the same place, right? Hopefully, I mean, what would be the ideal scenario would be that you win much more probability. Why? Because here in the inherent total, you're not spending any money. You're basically waiting for the risks to happen. And here you're spending, you see, $200,000. So that will be the case. Now, there's one thing that we left for the end here, which was the risk exposure. We didn't have a way to calculate that here. But what we can do is we can take a look to the results and say, well, what's going to be my P90? Here, my P95, for example. And I can see that in every one of them, you see that you have all these different tabs where you can see the percentiles, or you can build your own reporting. And this is what I wanted to show you. For example, you can say equal Guz sim percentile, and it says from this distribution, I want my 90%. And I will want the same thing for the other distributions, right? Guz sim percentile from this one, 90%, and Guz sim percentile, this distribution, 90%, because I really want to know what's my exposure. It says no simulation results, of course, so I have to run a simulation, so I get the simulation results, right? And this is going to, if you take this, you see, this is going to be that. So this is interesting, you see, because you have your P90 here was 5.2 million. That means that, let's say, that's the worst that you can do in the model. When you have the inherent risks, you see, you have almost 6 million, but with all the things that you did, even though you have the same probability of not reaching to the baseline case, now you have less exposure, you see? So all the money that we spent there reduced the exposure from almost 6 million to 5.6 million. So the idea is that you can play with things like the reference value. It depends on the methodology of your company. You can play with the exposure at certain percentile level. And basically, you can add or you can enrich the process of decision making. That's the most important part here, that you enrich the process of decision making by adding all these scenarios. You see that at the end, we build these 3 scenarios so people can decide better. Right? So this is the model that we wanted to show. Of course, thank you for joining. We're going to send you the model. We're going to send you the slides. And I'm not sure if there are questions. There are questions. Otherwise, I will let Loki finish the meeting with some information about new events in this month. There are questions, perhaps.
Gustavo, I just want to ask about the tornado chart that you mentioned. So the tornado chart, it looks like a great tool. Does it assign a value to each of those? Can you put, for example, I saw that the implementation of the pipeline had the highest deviation. Does it assign sort of a value so that you can say we'll add a control in around that, but we won't add a control because of course, there'll be like a cost-benefit scenario. The implementation of the pipeline, you might want to put a control around that, but not necessarily around design, as it isn't going to affect the deviation as much. Is there a way to see that?
Yeah, of course. What you can do, you see that this will be the first scenario, let's say. You see that the impact of the implementation of pipeline will go with between 4 and 5 million, right? In the model without any risks, right? And what you can do, you can take a look to the implementation pipeline to each one of them. You see that it's changed here from 4.3 to 5.8, you see?
Mm-hmm. Yep.
And also in the inherent, you have a 5.5 and here, and this is the effect that we wanted, right? is to have a less or a smaller or a bigger. So this could be one way of doing that, right? Which is what happened with the control but please remember, the control would affect the risks. In this case, the implementation of pipeline, you see here, doesn't have any controls. It's an uncertainty. So where you can do your analysis, right, is here, because for each one of them, you have a control that costs, and you have some impacts there. So you can do the same thing here, but you see here that I have my risk register variables and my cost variables. So I will say, I don't want to see my cost variable. And here, for example, the resource scarcity, I can do that in my inherent risk and see what are what is the scope there and compare with the residual one. You see? Let me take off. You see? So these are the types of stress analysis that you can actually do, but it's a really good question. And I think that we developed with you guys. I don't remember you were in the meeting where we developed this control ROI. Exactly. So these are the types of you can go really deep into that. But yes, thank you for that, because this is going to help also the audience to understand all the things that you can do with the controls. Thank you, Ben, for the question.